Hello,
Hello, Laurent. How are you?
fine, fine. I'm from Paris, so
There was something strange this time. The slides that were automatically uploaded were from something called ESDS, which seems to be a buff. They don't know how they ended up in our group.
hmm,
We had the slides uploaded correctly to our meeting, and they did not show. So I had to place them manually.
hmm.
It's very weird. Anyway,
I cannot tell you. Hope I will not have this in Vancouver.
I think there is a little bug
Ah,
that has sneaked in. So as usual, we're going to wait a little bit. And we were afraid that Alex would not be joining in time and would be a little late because of a train that happens to be late. So we'll see if Alex joins in the next minutes or... Oh, Alex, you're
I'm
here. Okay.
hi, hello, Pascal. I'm walking to my office, so you can start, but I'm listening. So I'll probably be connecting in 5 minutes. So it's okay, but you can start.
So I do the intro and you arrive. That's because your voice is muffled a little bit. I could not really understand.
Yeah, exactly. So.
Okay. Okay, time is time. So we'll be starting the meeting now. This is an IETF official interim meeting. And for the SCHC working group, if you care for another working group, then you're in the wrong place. As usual, the not well applies. So please be aware of the best practices in terms of anti-harassment. If you're aware of any harassment, then you may contact the Ombuds team, and you can see the link on this page. There is also a code of conduct that you're supposed to follow. And as usual, be aware that there is a regulation, BCP 79, about the way patents are disclosed and participated. So if you're aware of any IPR that has not been disclosed and that is presented during a meeting, please let us know or refrain to speak about that IPR. And the IETF, the agenda is very simple for today. It's continuation of the interim 2 weeks ago. So we'll soon let the floor to Carlos and Anna. Alex, do you want to speak the meeting, the Vancouver meeting? No, he's disconnected. Okay, so yes, we have a very good timing for our IETF meeting. It's on Monday, so on the first day of the IETF on July 22nd. And it's the first slot, meaning that people who stay in Europe will be able to attend this meeting. And effectively, that was our request. So the secretary did care about our request and managed to give us a slot that fits our needs. So we'll have 2 hours, which is theoretically more than we asked for, but that's fine. And we'll be so. Excuse me, my laptop did something weird. Okay, next slide. We so we have. Oh, Alex, you're there. Do you want to do the next slide?
Yes, please. Yes, and maybe just go to the previous one, because I just wanted to. I can go just back one slide. I cannot change the slides. Can you hear me? Oh yes, thank you. Yes, so maybe I missed the thing you said here, but one of the points is, so we have a 2-hour slot, so it's longer that we have initially requested, but I'm actually quite glad about this. So now we can go actually through the different drafts that we have been that we have in our list, and then basically do an overview of their evolution and what are the next steps for the different drafts. Right. So you can, yeah, please, next slide, please. Yes, and so we have very soon our call for adoption of the SCHC for zero energy devices that is ending. So it ends tomorrow, like in the evening. And until now, we have only positive reviews, so it's very highly likely that we'll adopt it. And one of the questions, I think the only question that remains somehow open is, should we keep the name as it is, or should we try to enlarge the scope from the get-go? So personally, I'd rather have the draft like a working group as a working group item, and then further on, clarify like we can add additional use cases, and at some point decide to rename it. So I'm not actually sure if that exists as a practice. I mean, I don't see any reason why not, but just in case, like I wanted to ask our AD. Pascal, I'm not sure, or anywhere here, Karsten, Carles, Marco, do you have any experience with that, like, or do you have any preference with that?
I have no special experience to answer on my side. I'm good with your proposal to adopt as is and see as we go.
Yes, but and of course we keep like the things that you said about like how would fragments behave when we have routing and we have these highly delay tolerant networks, highly delayed networks. I think these are topics to be studied and included in the future draft. But right now it's like a very like it's very well defined, and Edgar has and Anna, they have like a very specific problem topic. So I like this one.
And we have not necessarily decided if we go for standard status or something experimental or something.
Okay. So I mean that's for me. So Edgar, is this okay for you?
Yes, it's no problem. As long as we can edit it later if needed, then it's fine with me. The thing is that we realize that the zero energy device for cellular specs are changing, so there are new agreements. So we were thinking that that could cause that maybe the something called now LPWA could be more suitable for what we are proposing, but it's a little bit how can I say, like how the game goes in 3GPP. So it might be that it's not fully zero energy device, the ones who are or could use this. So that's why in certain way I'm thinking that it's good to keep in mind that the name may change depending of the use case. Do you follow my explanation, or did something happen with the...
Alex, I cannot hear you anymore. I see that you're trying to speak, maybe, but I'm not hearing.
Hello? Do you hear me?
Yes, Edgar, I can hear you.
Oh, okay, so you heard
But I
my
cannot hear Alex.
Okay, but you hear my explanation.
Yes.
Okay, thank you.
Alex, we are not hearing you. Okay, it seems that Alexander has some issues with his audio, but it's strange because the window is moving, but I'm not hearing you. Hello, Sergio. Okay, so let's move to the next slide. The next slide is the status of the documents. It's already obsolete, by the way, because we have published the draft IETF SCHC protocol number 00. So the last, well, if you go at the bottom of the page, you will see the draft inter-area SCHC protocol numbers. Well, this one is now replaced by a draft SCHC directly. So it's a SCHC workgroup document. So it will show maybe tomorrow or the day after on the first lines. It's not there already just because there must be a batch something which is running maybe at night, and that will compile the new page soon. But the draft is already available. Alexander, I'm still not hearing you. Okay, and so that's pretty much it. So we still have the Edgar, your draft, which shows us as new, but that's a discussion we had. And the milestones are not correct, obviously, and we are still wondering how to cover that. But there were a lot of discussions between the workgroup chairs about whether we need to have updated milestones, and we have to go through the ADs to validate that, etc. And since we are completely unclear about our milestones dates, for now, suggestion could be to just leave it at with those dates and do some best effort until we know better. Alexander, I see your messages. You said I had to cut my mic, and then it worked. I'm not hearing you. Can somebody else speak? Laurent, can you speak just to make sure that it's not on my side?
Hopefully you don't ask me to sing.
Yeah,
Okay.
we hear you.
Do you hear me?
Yes, yes. So let's move on then. That's the last slide.
Yes,
So
I have a
let's
question.
move on. Hello, Anna.
Yeah,
They
I
are
have a
because of
question.
the speaking anyway.
Yeah, I hear you. Are you planning that we present all the draft, the ongoing draft in the Vancouver's meeting?
Well, since we have 2 hours, I guess we can present everything we want, because we asked for only 1 hour, but now we have ample time. So we'll present, I would say, to death, everything that you guys want to present and hopefully discuss, right? We can present until death. I mean, until you're fed up with presenting and discussing. So yes, please. And let me share your slides, actually. So I don't know who's going to speak. Carles, Anna, Carles, going to be you?
Hello, yeah. So I will start and I will be presenting later. So I guess, well, can you hear me?
Yes.
Okay, thank you. So, first of all, thanks for this new opportunity to present this topic and to have the opportunity to discuss. So, as we quickly presented the other day, Anna and I are in the process of updating our 6.0 draft, which is entitled Transmission of SCHC Compressed Packets over 15.4 Networks. And basically, the main update will be trying to align the 6.0 draft with the SCHC architecture concepts, especially those that have been introduced in version 0.2. So we would like to share our current thoughts on that, what we are planning to add to the draft, and see what you think, guys. Okay, so as introduction, the main incentive for trying to use SCHC for header compression over 15.4 networks is that the expectation is that it should provide a better performance, greater compression ratio. And related with that, we have always as a main goal trying to keep a low header overhead to the extent possible. And on the other hand, well, now in version 0.2 of the SCHC architecture draft, the SCHC header concept has been very much developed. There are some new related concepts that have been introduced. And as you will see later in the presentation, what we are planning for 6.0 regarding the SCHC header is that in some scenarios, it is possible to have it fully compressed, meaning 0 bits would be transmitted over the air, similar to what we have been doing in the past in the LP1, or when compressing IPv6 packets over LP1 technologies. And in some other scenarios, we really need some SCHC header which is not fully compressed, and in that case, ideally, it should contribute a low header overhead. So as you may recall, the main problem in SCHC header compression over 15.4 networks is multi-hop communication. So for that, there is route over and mesh under. And for route over, there are 3 modes that we are considering. The first one is straightforward route over, so meaning that the intermediate nodes, all the routers in the network, store the rules for compression and decompression that are used in the whole network. So this has the advantage of incurring the lowest header overhead. However, as you can imagine, this may pose significant challenges in terms of scalability. Therefore, we have two possible alternatives trying to avoid the intermediate nodes, those routers, having to store all the rules for compression and decompression. The first one is tunnel-based route over. This is when a network is using Ripple in non-storing mode, then it is possible to exploit that so that when a source transmits a packet to some destination, the packet is compressed and then it's sent through a tunnel up to the root. And then if the destination is internal to the 6LoWPAN network, then there's another tunnel downward from the root to the destination. And then there is the third mode, which is pointer-based route over, or as an internal joke, we call it PRO sometimes. The idea here is to avoid the intermediate routers to have to store all the rules for compression, decompression. Then the SCHC compress packets are prepended with some pointer, which then indicates how to locate, how to find the compression residue for the IPv6 destination address, so that a router that receives a SCHC compress packet, even if it doesn't store the rules for decompressing it, it's still able to reconstruct the uncompressed IPv6 destination address and then perform its usual routing operation. So then for the 6.0 draft, we are planning to introduce first like a classification of two possible network types. Yeah. Okay, so here we introduce the concept of single instance. Yes, sorry?
Sorry, I had raised my hand quite a bit of time ago, and I didn't see that whether you could take the question or the point, or you want to wait till the end, but I was not sure you've seen it. So I'm just interrupting to say, how do you take raised hands, basically? Do you want to discuss everything at the end of your discussion, or do you accept discussions within your slide?
Yeah, I guess that it may be good to discuss while seeing some slides, because maybe there are some details in the slides themselves. So I think you can interrupt me as you wish. And by the way, sorry, because I really hadn't realized that you had raised your hand. Yeah, now I'll be looking at that. So, okay, so did you have any actual questions?
Yes, I had two comments. I raised my hands when you said that straightforward may be very, very complicated because of the set of rules. I would say there are really two cases. One case is it's a very homogeneous network where all the devices are pretty much the same, like a YSAN network, for instance. Like every device is YSAN approved, and I guess YSAN would publish the rules as part of their standard if they were to use LP1 SCHC. In that case, I mean, the only field that revariates from one device to the other is the IP address of the device itself, but otherwise rules would be the same for every device. And if I remember well, in the case of YSAN, because they wanted to have a good 6LoW compression, they used the HCP for forming the address, and they ensured that only 2 bytes of the suffix are non-zero. So you have only 2 significant bytes in the interface ID part of the IPv6 address. And that makes it so that the SCHC compression would still work very well, and you could have a single set of rules, and you would just not compress those 2 significant bytes in the interface ID. But otherwise, the network would work really well with straightforward. So just an example that SRO is actually very meaningful, because there might be a good number of networks like this where the rules are network-wide. So I don't think we need to bar or straightforward. SRO is a good model for a particular case. Maybe we can just say that in the draft, that it becomes complicated if every device has a different set of rules. But if the rules are the same, and for instance, the IP address has some bits which are not compressed, or you have a very long index with all the addresses present in the network, that could happen as well. Then it's doable. I mean, it works.
Thanks a lot. Because
the other thing I wanted to say later was when you introduced tunnel-based, there are effectively some networks like a Ripple network where the tunnels are there anyway. So tunnel-based in a Ripple network makes a lot of sense. So then again, there are some applicability discussions that we can make, saying, hey, straightforward can be a very good idea if you have very homogeneous networks. Tunnel-based is a very good idea in the case of a Ripple network, and if you're okay to do tunnels, then it's a good option. And by the way, reference to Sixth law, the RFC8138 has a very good compression for IP and IP tunnels. And yes, that's what I wanted to say. So on SRO, don't dismiss SRO too much when you speak it, and please. And yes, applicability could be discussed for both cases.
Okay, so this is great feedback. Thank you. Because actually, I'm kind of quite a fan of SRO, although we were discussing it and so on. We were aware that in some cases, at least, it might lead to challenges of scalability, but it's also good to take into consideration what you said, that in some scenarios, it may also be like very applicable, because then it has the advantage of the lowest header overhead of all the different modes we are considering. So that's great to know. Okay.
Yes, the other suggestion for PRO, actually, for pointer-based, would be to discuss the security aspect of it. Because if the packets can be tampered with, or if there is any bug, the pointer can lead to the very wrong place, and then all bets are off. So in terms of risk, quote unquote, it might be that pointer-based is risky.
Okay, yeah, so that's one point we hadn't considered yet, so thanks also. Okay, so then continuing with the slide.
Just one point. Excuse me,
Yes,
I was in the queue just to answer to Pascal, but if you can change a pointer, you can also change the destination address or the residue, so it's kind of attack too, so I think it's at the same level.
So you mean it's not specific for this mode, for pointer-based?
If you can change a pointer, you can change everything.
Yeah. Okay.
Well, it just opens a new form of attack. But I agree with what you said. You can change anything. It's just that more bugs and more attacks are possible with pointers, because yes, but maybe it doesn't make a big difference, but that's worth discussing in the security discussion, even if it's to say what you said, Laurent.
Yeah, great. So thank you. We will do that actually. So so continuing, we identified that there are two possible network types, what we call single instance networks, where all devices in the network use a single SCHC packet instance. And in this case, what we plan to require is that the SCHC header must be fully compressed in this case. And for multiple instance networks, well, this is networks where there are at least some devices in the network that use more than one SCHC packet instance. In that case, as you will see, the SCHC header cannot generally be fully compressed, although there are a few exceptions there. So, okay, now we'll see a few examples, first with single instance networks and then with multiple instance networks, of how things would work and what it means in terms of fully compressed SCHC header and some constraints or requirements on how the rule IDs and the rules can be used. So this is single instance networks. The example here is for straightforward SRO. So you can notice how in this example network, the 6 LRs in the middle are storing the rules that are used in the network. And here, you could say host A is transmitting a packet to host C. It uses rule ID 2 to transmit, well, to compress the packet and then send it. So the next node is the leftmost 6LR. So because it stores the rule with rule ID2, it will decompress the packet. It will know what to do with that. It will perform its routing operation. So everything seems to work. And here, actually, the SCHC header can be fully compressed. And the only requirement here would be to avoid possible ambiguities that rule ID and its corresponding rule must be unique network-wide. So this is for straightforward route over. So moving to the second one, a tunnel-based route over. In this case, you may notice how the 6LRs in the middle do not store the rules for compression and decompression. And in this case, let's say that host A is sending a packet to host C. Then again, it will compress the packet. It will use rule ID2, will send the packet through the tunnel, and the compressed packet will arrive at the 6LBR. So the 6LBR has to store all the rules here. And in this case, well, because this is a single instance network, it just applies, it uses the rule ID, well, the rule identified with rule ID2. It's able to decompress the packet and decide what to do with the packet. So here things will work as well. And again, one requirement would be that because the 6LBR needs to store all the rules that are induced in the network, then also the rule ID and its corresponding rule must also be unique network-wide. So yeah, I think Pascal and then Alex, you have comments?
Yes, my first comment is I realized that you probably reused the drawing and did not adapt it fully for our case, but a host, what I'm fighting against here is the term host and 6LR. If you're doing the tunnel, like a ripple tunnel, you are a 6LR, meaning you're the source, you're the SCHC endpoint, very precisely, you're the SCHC endpoint, but you're also a 6LR. And you're tunneling your own compressed data. And so, yes, the first 6LR after that has no rule, but what you call host A, for instance, is a 6LR and it has the rules. And it does the tunnel. I guess that's what you had in mind when you said 6LR has no rule, correct?
Yeah, and then there's another point. So in the document we have, actually we use the term routing aware leaf.
Yes,
for host A.
It's a leaf, but a routing aware leaf is a router because it contributes to the routing protocol. So RAL is okay, it's perfectly okay. And that's the best. Maybe if you take a REPL example, if you take a non-REPL example, I guess you still need to call it a 6LR unless the host is capable of tunneling. But it's not a host necessarily yet. It is a device. For us, I would just say SCHC endpoint. So you don't have to say if it's a host or a 6LR or anything. It's just the SCHC endpoint is the tunnel endpoint. Now there is another possibility, which is more like your drawing, where the host A is a ripple unaware leaf.
Yeah.
In which case, the 6LR is the one doing the tunnel, meaning the 6LR has a minimal need of understanding the compression because it needs at least to realize that the packet has to go, well, it has to find host A in the packet. For packets going up, it has to find the root, but you could expect that anyway it goes to the root because they always do. But in non-storing mode, but for the way back, when the packets come from the host, the packets come from the root, and the 6LR terminates the tunnel. The 6LR has to know to which host A it has to, which ripple unaware leaf it has to pass the packet.
Yeah.
So in that case, there is a minimal understanding of the rules by the 6LR.
Yes.
So
yes.
That maybe you would say, okay, that's equivalent for the 6LR to the SRO, because it has to be aware of the rules of at least all the hosts which are attached to it. So it could be seen as an SRO. I'm not sure.
Yeah, so I think we have text in the document for distinguishing the two cases, the routing aware leave and routing unaware leave. But then, yeah, we may need to see to have examples which apply in both cases or clarify or avoid ambiguities with this. And yeah. So yeah, thanks a lot. Yeah, Alex?
Yes, one very short question and then another one. So here the SCHC header that you say that is fully compressed, here you understand that's the residue, right? That's the compression residue from the packet header or not?
Well, this is the SCHC header.
Yes, you have the rule ID, and then after the rule ID on the wire is the compressed 6-loop header.
No. Yeah. Well, there are two things here. One is the SCHC header in terms of what is introduced in the SCHC architecture draft version 02. And then the other thing is what comes next, which is the SCHC compress packet.
Yes.
And then the rule ID mentioned in the third bullet corresponds to the SCHC compress packet, not to the SCHC header. So yeah, I understand that there can be some confusion about.
I'm actually rereading right now the whole architecture draft and trying to, because there are some overlappings and some ambiguities. So I'm trying to clear this out. So I just wanted to understand on the wire here we have like the rule ID, and then on the wire afterwards you have like you have direct. What do you have after the rule ID on the wire?
Yeah, so on the wire, later you will see the formats actually. Let's see. Can you see?
Okay, yes.
Oh, sorry. Well, for some reason I'm not. Yeah, this one. Okay. Can you see? Well, in the current slide, the idea is that we have what is in the new format, the one below. There's the red lines highlighting the location of the SCHC header. And after that, there's the SCHC compress packet. So this is for the tunnel base.
The SCHC compress packet, that's the residue of the compressed header.
Well, so what I was saying was, in a single instance network, you can transmit 0 bits for the SCHC header. So the field which is in red here. After that, there's the SCHC packet, which is defined in RFC 8724, which is, say, an IPv6 packet with a header, an IPv6 header that has been compressed by using SCHC. So,
okay.
Yeah.
Okay. Yes, exactly. So, I mean, this is what I call the residue, right? This is the compression residue. In RFC 8724, we say that we have the SCHC compressed header consists of the rule ID and then the compression residue.
Yeah. So let's say
and so here we have that we have the same thing, like the rule ID and the compression residue. There is nothing in between, right? It's 0 bits. Yeah.
Yeah. So the SCHC header would be 0 bits if it can be fully compressed. After that, there would be the SCHC compress packet as usual, what we have been doing previously, and so on. Yeah.
Yeah. Okay. So I mean, at least for me, that's clean. That's understandable, right? I mean, one thing is, I think there is a slight ambiguity here in the term SCHC header, and I'll try to clear that, but that's going to be another story. Just for me. Okay. So that was the first question, and the second question here, because I see that I mean, I like this the way we present the setup, and it's really nice. So the rule IDs, the way they're used, that makes me think of somehow MPLS and MPLS labels. And the question is, when you go to the 6 LBR, how do you know? I mean, you have rule ID. How do you know that it will route to host C to host C and not back to host A?
Well, basically, the rule allows you to decompress the IPv6 packet header, so you can see which is the IPv6 destination address. And from that, you say, okay, the IPv6 destination address is that of host C.
Okay, yeah, okay. And in the intermediate, then you're tunneled, so you don't need to have this information.
Exactly.
Okay, okay.
Exactly. Yeah. Okay, so this was for the tunnel-based route over. So then the next one is the pointer-based. So here, well, the example is slightly modified. You can still see that the 6 LRs in the middle do not store any rules. And now what we can see is that, well, we have in this example 2 different rules with the same rule ID. One, well, this is rule ID 2, and one rule is for communication between A and C. The other one is for communication between D and B, and however, both are using rule ID 2. So here, the idea is that, let's say that host A is transmitting again a packet to host C. It compresses the header with rule ID 2. So this packet is sent to the next hop, which is the upper 6LR. And then the 6LR, thanks to the pointer, even if it doesn't have the rules, it's able to determine which is the IPv6 destination address of the packet, and then send the packet to the next hop and so on. So because this is single instance, it will work as we can see. So the SCHC header can be fully compressed, 0 bits over the air. And then the other thing is related with the 2 different rules with the same rule ID. This is possible if there are disjoint pairs of endpoints that use that. As you can see in this example, where, well, A and C use some rule called rule ID 2, and nodes D and B also use rule ID 2, but they are possibly, perhaps they could be different rules. So yeah, Pascal.
Yes, that's what I was referring to earlier. Just to point out, when I was discussing that we can be working for ripple unaware leaves, effectively the ripple unaware leaf would have to operate as a PRO for the leaves that are attached to it. So it can effectively deliver the packet. But then once it's in the packet in the tunnel, the core routers inside the network would not need to see at all the SCHC compression. So that, yeah. I was kind of imagining that hybrid of tunnel-based to TRO and PRO, where the routers in the middle just see the tunnel, so they don't see SCHC at all. But the care of routers, if you like, the routers which care for the SCHC devices, for the ripple unaware leaves, then they need to have a way to find the IP address for the last hop.
Yes.
So they undo the tunnel, they get the compressed data, they need to deliver the packet. So those ones would be needing something like PRO to find the device. So it's kind of an hybrid where only the first hop router is PRO, and all the others are nothing. They're just TRO. They're not aware at all. So you see my drift?
Yes. So I think this is very useful because actually we have some text in the document for that first hop or last hop, but it's not so optimized. So I think, if I understand correctly, we could use in that case something like PRO to improve things. And yeah, I think that
yes, PRO in the access router and then TRO in the rest of the network, meaning nothing.
Yes, yes. So I think that's a very interesting proposal. Yeah, thank you. Okay, so yeah, Alex.
Okay, no, please go. I mean, yeah, one thing I wanted to ask you here, because we are like discussing of hybrid solutions. Do you think there would be a way where we can have, let's say, well, maybe not all pairs of destinations, but like you can enumerate the destinations, and you can have rule IDs pointing to these destinations that are like numbers. So each of the routes needs to have a table that says, okay, well, rule ID 1 needs to go to host C, rule ID 2 to host B, rule ID 3 to host A, and so forth.
So do you mean each node, each host, let's say, having a table like that?
Yes.
You mean as a way to say that the rule identifier somehow is related with the endpoint identifier?
Something like this, yeah. Yes.
Yeah, maybe. Yeah, I hadn't thought about it. I'm not aware of that idea discussed before, but yeah, maybe it could be also some interesting optimization.
Laurent, you wanted to say something?
Yes, two things. First, to have a rule ID, you need the set of rules, because the rule ID length is not specified. So the only way to know what is a rule ID is to have the set of rule, the first point. So maybe you can have a very small set of rules just with the rule IDs and nothing after, but I don't see the benefits. And the second point is you may have a rule ID, and in fact, the address, destination address, is in the residue. So you cannot just do routing on the rule ID.
Yeah. I mean, the point here was, of course, that you have the same set of rules in all nodes. Let's say on over, I don't know, if your network is 200 devices, like one bit is enough, and that's like labeling the destinations. And then you can have in the residue, you can have more like additional information that you need. Okay, that comes from this other node or something, right? But I mean, I was really not aware, and I like the way you presented Carles and the questions from Laurent, from Pascal. They made me think. Okay, well, maybe there is, for some kind of networks, like that could be that are stable enough and so forth. You know, like and that could be something to look at. I don't know. It will depend on the topology, right?
Yeah, definitely. Yeah, thank you. Well, so finally, still in single instance networks, well, this is mesh under. The only difference, well, apart from routing going below IP, is that instead of the routers in the middle, we have mesh under forwarders, but more or less, well, the topology is similar. And here, the same conclusions would apply. Here, this can work if the SCHC header is fully compressed, and the requirement for the rules and their rule IDs is that disjoint pairs of endpoints may use the same rule ID, even for different rules. So this was for single instance networks. Now, what happens in multiple instance networks is, summarizing a bit, that the SCHC header will not be possible to have it fully compressed, at least in most cases. So here we have an example for straightforward route over. As you can see, there are two SCHC packet instances used by each node actually here. And one is identified as black, the other SCHC packet instance is blue. Each one has its corresponding set of rules. And here, for example, we may have some problem, which is, imagine that host A receives a SCHC compress packet with rule ID 2. Then the question is, okay, which one is the rule I need to use? Is it for host A to decompress a packet with rule ID 2? Is it the black one or is it the blue one? Okay, so then we need the SCHC header not fully compressed to be able to distinguish which one is it. So this is for straightforward route over. Then in the tunnel-based network, it's quite similar. So again, imagine host A receives a SCHC compress packet with rule ID 2, but then we need something to tell us which one is it. Is it the black one or the blue one that we need to use to decompress the packet? There's no other way to know. Then for Pro, there is also something similar. So host A could receive, again, a SCHC compress packet. The compress header is rule ID 2. So again, the host A will need something to allow to tell, okay, is it the black rule ID 2 that has been used to compress this, or is it the blue one? So still we need some SCHC header which cannot be fully compressed. And then there is, in some cases, an exception. here in mesh under, because well, we have a similar example to the previous ones, but in this case, imagine that host D is sending a packet to host A, and it uses rule ID 2. Could be the blue one here. And okay, so this is mesh under. The packet will be sent by host D. It will be forwarded by node M, and then it will be delivered at host A. So in this case, the point is that host A sees that, yeah, the compressed packet has rule ID 2. So then which one is it? Is it the black rule ID 2 or the blue rule ID 2 that has been used to compress the packet? Well, in mesh under, in this case, it is possible to determine who was the source for this packet. This is because in the mesh header, it contains the address of the source. So in that case, it is possible to tell, okay, the source was host D, so it is the blue rule ID 2. So in this particular case, the SCHC header can be fully compressed. However, if we have some other scenario, like imagine, perhaps quite extreme, but that there are between the same two endpoints, host D and host A, using rule ID 2 both, but one in the black, one in the blue instance. In that case, we cannot tell from the receiver, based on who was the sender, we cannot tell which is the right rule ID that has to be used to decompress. So for that, we really need the SCHC header, which would be not fully compressed. Yes, Laurent? Hello, Laurent, can you hear me?
Sorry, I press on the hand and not on the mic. So thank you for writing a nice illustration for SCHC header and the use of session ID, or if my memory is good into terminology. But so that's good illustration. But for me, this is more in the SCHC part that we have to specify that. It's something very generic than just for 6-flow networks. So I think if we say we have SCHC over 6 flows, then we have this property that comes with it.
Yeah. So yeah, that's one point. Possibly the discussion about single instance and multiple instance, and perhaps related with multi-hop networks. Yeah, that's probably more general than just our draft, which is focused on 15.4. Yeah, we may need to double check, but perhaps it's a bit more like in the field of architecture. Yeah.
But that's good to think about that here.
Yeah. Yeah, I agree. Thank you. Okay, so just quickly, well, this is how the frame formats would be modified when we include the SCHC header. Alex?
Yes, just because I like very much the presentation and discussion. We have around 7 minutes, so just that you know about your time.
Yeah, I think we can be fast for the next slides and hopefully have some time for Anna's part.
We have nothing after this, so like we just dispose with the time as you have. But in case you have a lot of things to say, just know that you have 7 minutes.
Yeah, thank you very much. Okay, so this is the different formats now, including the SCHC header, which again would represent 0 bits over the air if it's fully compressed. So you can see highlighted in red that now the SCHC compressed packet, what's called the SCHC packet in 8724, now would be prepended with the SCHC header. This is for straightforward route over. This one is for one of the formats used in the tunnel-based route over. This is the one in Pro. Some minor detail here is, well, this is the Pro header. This is what comes right before the SCHC compressed packet. So the SCHC header should come naturally, let's say, right after the address length field. However, to avoid complicating a bit more the bit pointer field, we are a bit more inclined to including it here, like in the middle of the Pro header, as you can see, only for that reason. Okay, and then there's the mesh under format, which again inserts the SCHC header right before the SCHC compress packet. So we also plan to add some section in the draft summarizing a little bit how the main SCHC architecture concepts apply in our draft. So for single instance networks, we understand that the SCHC header is fully compressed. Then there's some SCHC header instance which contains one set of rules that contains a single implicit rule or is equivalent to that. And then there's only one SCHC packet instance because there's a single instance networks. And then about the SCHC stratum, we understand that it's located at layer 2.5 because it's on top of the link layer and below IP. And the compressed data part of the SCHC stratum may or may not, but it may comprise all upper layer packet headers simultaneously. Like you could jointly compress IPv6, UDP, and COAP headers, for instance. Then the discriminator, we understand that it would be the SCHC dispatch or the SCHC pointer dispatch because it's the first field, leftmost field in the frame 15.4 frame payload, which then indicates signals that what comes next is a data unit where SCHC has been used to compress it. And for multiple instance networks, we have a SCHC header, which would be compressed, but generally not fully. There's a SCHC header instance with one set of rules, which in this case may comprise several rules. Then there's the, several SCHC packet instances in this case, each one with its corresponding set of rules. And the rest is the same as in the previous slide regarding the SCHC stratum and the discriminator. So I don't know if there's comments about this. Otherwise, I guess that perhaps Anna, if you want to present, I can browse the slides if you wish.
Yes, thank you. So the last part of the presentation was about the transition protocol stack, where we were planning to use the RFC 6282 to compress the IPv6 header, together with SCHC for UDP COAP. And then here, with the new architecture draft, we need to identify the UDP header and the COAP header. So next slide, please. So the question is, we are only having one stratum for UDP and COAP after the IP header, so in layer 4. After layer 4, we are making a stratum, a SCHC stratum for UDP and COAP. And while I was defining the SCHC header, my question is, do we need to have a SCHC header for UDP and a SCHC header for COAP, even if we are using one stratum?
Hello, Anna. My understanding of what we've been doing is it's one SCHC header per stratum. That's why in the recent exchanges we had, I was talking about calling it a stratum header as opposed to a SCHC header, because we've seen again today that there is a huge confusion when we talk about SCHC header. People wonder if you're talking about the SCHC header as we define it in the architecture, which is what you're doing here, and what Carles has been doing, so we are fully in line, or if it is the rule ID plus residue that we call the SCHC header, which is probably what we used to use for a long time. So as you point out, there is only one, what the architecture calls SCHC header per stratum. So
Okay.
we could call it stratum header in my mind, as opposed to SCHC header, just to avoid the confusion.
Yeah, we can call it SCHC header stratum, or the stratum of the SCHC header, however you want. And the question is, so here, if I put two SCHC headers, so I have two stratums, and then if I have two stratum, is the same endpoint.
So maybe from my view and what I understood, if you do compression of COAP and UDP on the same rule, then you just need one SCHC header that will replace the port number, the IP protocol number that in the compressed part is carrying SCHC, And then when you have done the compression, you swap it with UDP.
Okay, I
If you
understand.
have two stratum, one for UDP and one for QAP, then you need two SCHC header. The first one that when it's compressed is the IP protocol, and then you have a port number that points to SCHC decompressor, and then you swap it to the QAP port.
And when you are using two stratum, is because you have two endpoints, or why?
No, it's because, for example, you do the IP compression up to the LP1 networks and the co-op compression on the application.
Okay, thank you.
Which is a yes then, Laurent, because we could consider, it depends what you call the endpoints. If it's a physical endpoint, it's the same device. But if you're talking about a logical endpoint, one is in the network layer, one is in the application layer.
Okay.
It's a stratum endpoint.
Yes.
Yes, so that's why I suggested to call what we have been calling so far the SCHC header, suggesting to call it the SCHC stratum header or something. So we are very clear that we talk about what works for the stratum as opposed to the rule ID plus residue.
Okay, so I have to modify this and only use the SCHC header stratum after the IP header. So we will only have in one
stratum header, if you don't mind. It's the stratum header, the header for this stratum, but because it's SCHC defining it, it becomes the SCHC stratum header.
Yeah.
Yes, I think that first we need to really clarify the like among us and on the SCHC architecture draft, and then like do other changes, because it's a little bit a moving target. So we understand each other, but let's first define that in the SCHC architecture, in the 03 version of the SCHC architecture draft, that the whole terminology is really cleared out there, and then of course it's we can put it like here, and you're right to ask the question, Anna, and I see what you mean, and yes, I think we understand it. Just that we use we write down the exact meaning, and then we use that.
And my other question is about the session ID. So the session ID is linked to the instance.
Okay, I think that we should treat this one in the in a different we're a little bit over the time now, so it's not a question for now. It's a
okay. Thank you.
Says yes, but yeah, it's like a large question for me. So let's treat that one. Yes.
Okay, thank you.
Okay, so you have one more slide, I think.
No, that was my two questions.
Oh, okay, sorry.
And we are just out of time anyway, so it's a great time to conclude. If anybody has one question or two, and then we will close this meeting. No question. I'm not hearing anything. I'm not seeing any hand. Okay, so with this, we thank you all for attending this meeting, and those were great discussions. And then again, we have a finger pointed at the architecture to really define what's needed and be very precise with the terminology. So we'll be working on this.
Yes, I think we need to get the 03 before the cutoff. If we can.
Okay.
That's a very, very ambitious thing, but let's try.
You guys take care.
Yeah.
It depends on you.
Bye.
Yes. Bye all. Thank you, Carl.
Thank you.
Bye. Thank you.